This is lesson 3.2 of our Pre-Calc 12 class. Unit 3 is called Trigonometry, and lesson 2 is called Coterminal angles. In this lesson, we're going to talk about how do we understand angles greater than 360 or less than 0 degrees, or as we know now, greater than 2 pi or less than 0 still. But we're also going to talk about what are coterminal angles. So if I'm looking at ridiculously large angles, as we count an angle on the unit circle, we're going counterclockwise, which might be counterintuitive. Unless you're thinking of quadrants 1, quadrant 2, quadrant 3, quadrant 4 on a graph, then maybe counterclockwise might be just what makes sense. Anyways, when I say 90 degrees, we start at angle, what we're going to call our standard starting position on the unit circle. So just like, from the origin to the right. 90 degrees or pi over 2 means we go straight up. So we get a right angle right here. 180 degrees means we keep going counterclockwise until we hit the other side of the x-axis. 270 and then 360 comes right back to 0. So because on the unit circle 0 degrees and 360 degrees both end or both terminate at the same position on the unit circle, we're going to call those 0 and 360 are coterminal angles. Both. If we add another 90 degrees to 360, we get back to our straight up position. 360 plus 90 is 450. So we can also say that 90 degrees and 450 degrees are coterminal. I technically shouldn't be putting an equal sign there because 90 is definitely not equal to 450, but they are coterminal angles. We can express that same thing in radians. So 90 degrees is pi over 2. So 90 degrees plus 360 gets us back to 450. So we can take pi over 2 and add 2 pi to pi over 2. And we get 450 in radians, which would be 5 pi over 2s, or 1, 2, 3, 4, 5 right angles around the unit circle. And then we could say that pi over 2 and 5 pi over 2 are also coterminal angles. If we add 2 pi on top of 2 pi, we get 2 full rotations around the unit circle. So we could also say that 4 pi is coterminal to 2 pi and 0. 4 pi would be doubling 360, that would be 720 degrees. So we could also say that 720 degrees and 360 degrees and 0 degrees are all coterminal angles. And we could do this all day. If you go a ridiculously random big number like 1090, and you want to find what's the coterminal angle between 0 and 360, just take 1090 and subtract 360 and subtract 360 until you get into that range. If we subtract 360 3 times, I think 360 times 3 is 1080. So if we subtract 360 from 1090 and we subtract 360 again, and a third time, we should get 10 degrees. So that we can say, in conclusion, 1090 degrees is coterminal to 10 degrees. Okay, I'm beating that one up. Negative angles. So if we go clockwise on the unit circle, we can, essentially what we're doing is finding negative angles. So if 90 degrees is going counterclockwise, straight up, negative 90 degrees will be going clockwise or straight down. So this would be negative 90 degrees here in purple. Negative 90 degrees would end up in the same spot as positive 270 degrees. So we can also say that 270 and negative 90 are coterminal angles. And we could pick any angle here. Negative 360 degrees would be coterminal to 360 degrees because they both end in the same spot. Negative 270 would be coterminal to positive 90. So that's negative angles. All right, So let's talk about show the given angle on the unit circle. Can you draw the angle? So 390 degrees would be somewhere about here. It's 360 is one full rotation. 390 is going to be 30 degrees beyond one full rotation. So 390 is basically graphing the same angle measure as 30 degrees. So it'll be somewhere around here in quadrant 1. Negative pi over 2 is negative 90 degrees. That's clockwise straight down. There it is there. And negative 700 degrees, 705. We'll go 360, and then another 360 would be 720. But we only have negative 705. So we're 15 degrees shy of 2 full rotations. So that means negative 705 degrees is going to be coterminal to 15 degrees. So that's definitely going to be somewhere right here in quadrant 1. It's going to be half the angle measure of 390, because 390 was coterminal to 30. So I could figure halfway between 0 and 390 is going to be negative 705. Okay, 680 degrees. That's a rotation and a partial rotation. So we got 360. Another 360 degrees would be 720, but we're only at 681. So that's going to be 39 degrees shy. 720 minus 681 is 39 degrees. So we are 681 degrees is going to be coterminal to negative 39 degrees. So somewhere around here in quadrant 4, we have this angle measure right here of negative 39 degrees, and it's going to be coterminal to 681 degrees. Okay, and we can find the coterminal angles for each of those. We've kind of already talked about it in the last slide, so just kind of explicitly saying, here are the coterminal angles between 0 and 360, or in case of example B, between 0 and 2 pi. 390, if we subtract 360 from it, we're pulling off one rotation, we get to 30 degrees. So that's going to be the our coterminal angle between 0 and 360. Negative pi over 2 is the same thing as 3 pi over 2 is in the positive. Negative 705 is going to be the same thing as 15 degrees, because remember it was 15 degrees away from 2 full rotations, which would be 720 degrees. And 681 degrees is going to be coterminal to 321. Remember, it was 39 degrees shy of 2 full rotations. And so negative 39 degrees would be coterminal to 321. The calculation would be 360 minus 39. Okay. We can now do trig. We now have the pieces in place to do trig with angles larger than 360 and angles less than 0. And we've also figured out how to understand coterminal angles. And we can represent coterminal angles to turn any angle into a coterminal angle between 0 and 360, or 0 and 2 pi. Which we can use now because I'm looking at trig functions again. Ho ho.